Alright, let's look at example 7. X to the 6 minus 64 over x minus 2. Now, x is approaching 2. If I substitute 2 into the expression, I always start there. Obviously, I'm seeing 0 on the bottom. That's easy, 2 minus 2. If we do 2 to the 6th power, 2 times 2 is 4, 8, 16, 32, 64. 64 minus 64 also 0. So we got our indeterminate form of 0 over 0 happening again. It would have been nice if it was, let's say, 64 over 0 or 32 over 0. Then we could just put our chart in, go to whichever infinity and be done. But instead, they're going to give us this indeterminate form, so we're going to have to do some factoring, maybe. I'll give you another option other than factoring. In this specific example, you could divide. Long division. X minus 2 into x to the 6th plus 0x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x minus 64. Do all the division stuff, and your quotient will not have an x minus 2 on the bottom. That works also. That's a lot more tedious than what I'm going to show you. What I have on top here is a binomial. The 6 is even, the 64 is a perfect square, so it is a difference of squares. The 6 divides by 3, the 64 is 4 cubed, is also a difference of cubes. Going back to geotrig, we dealt with this specific example, factoring this completely. And I told you, anytime you factor a binomial, your checklist is number 1, greatest common factor. No. Checklist 2, difference of squares. Checklist 3, sum or difference of cubes. That's your list. That's how you factor. Okay? So, what I would do here, limit as x approaches 2. I'm going to keep my x minus 2 on the bottom. I'm going to factor this as a difference of squares. So parentheses, parentheses, one sum, one difference. And what I want to do is I want to take the square roots of the two pieces. The sum of the square roots and the difference of the square roots is the factored form of a difference of squares. When you square root a power, you just divide the power by 2. So x to the 6th, the square root is going to be x to the 3rd. 64, the square root is 8. Looking at the two top pieces, x cubed plus 8, x cubed minus 8, you'll notice that this is a sum of cubes. X is cubed, 8 is 2 cubed, they're being added together. That factors. This is a difference of cubes. X is cubed, 8 is cubed, they're being subtracted. That also factors. These both factor again. Which one's going to create the x minus 2 I'm looking for?
Negative 8.
This one, right? So I could factor this if I felt like it, but I don't have to, because my goal in factoring here, always when you look at your mathematical problem, ask yourself, what is my intention? And then follow that intention. Do what you have to do. I could factor x cubed plus 8. I don't have to. So I'm going to leave it alone. I can factor x cubed minus 8. I need to, so this x minus 2 goes away. So if we focus in on just the x cubed minus 8, everything else is going to stay the same. So limit as x approaches 2 of x cubed plus 8 over x minus 2. All that's staying the same. I'll do this part in red. Factoring a difference of cubes, if you recall back from the end of Algebra 2 towards the beginning of geotrig, we dealt with that again, and sort of midway through the first semester of geotrig, we did it again. You take the cube roots of both pieces with the same sign. The cube root of x cubed is x, the cube root of 8 is 2. The sign between them is negative. The second parentheses is created from the first parentheses. You square this, you multiply together, you square that. So square, multiply, square. The signs go as follows. Same sign as you started off with, minus, minus, opposite sign, plus. It should be squared. Thank you, David. Yes. So once again, just so there's all on board correctly with what I'm saying, x to the second power, x times 2 is 2x, 2 squared is 4. The signs are the same sign as we started off with. This is a minus, so it's same sign goes there, minus. This is always opposite, this is always plus. All right, and just like that, we've got the x cubed minus 8 factored, and just like that, x minus 2 on top and x minus 2 on the bottom cancel, getting rid of that x minus 2. Again, I could have factored x cubed plus 8, but there was no purpose in doing it, so it's fine the way it is. Finally, now that the x minus 2 is off the bottom, there's no more division by 0. Now substituting 2 in should give me a result that's not 0, or not undefined or indeterminate. So if I look at this, I've got object being multiplied by object. I want to evaluate this and evaluate this, then multiply those two evaluations together. So if I put 2 in here, what am I going to get out of this whole parentheses? 16. 2 to the third is 8. 8 plus 8 is 16. Okay, if I put 2 into the red one, now this is a little bit more elaborate, so let's just look at each piece. 2 squared is 4. 2 times 2 is 4. 4 is 4. 4 plus 4 plus 4 is 12, right? And 16 times 12 equals 192, which is the answer to the problem. And once again, if we just take a look over here real quick at my calculator, if I had gone over here and typed in x caret 6 minus 64 divided by parentheses x minus 2, and I'd gotten really close to 2 from both sides, 1.999 gets me to 191.9760016. 2.0001 gets me to 192.02400016. Again, maybe the educated guess you get out of that's 192. I don't know. But you can get even closer if you want. Get a bunch of zeros going, see what happens. Say 192. And that is dead on 192. Alright? So, again, if it comes down to it and you're like, I don't remember how to factor this thing, maybe a numerical chart can get you the answer. If you do the numerical chart, I'll expect to see that on your paper. I want to see that you did it that technique. If you're making good educated guesses off of it, I don't have a problem with it. This technique is foolproof, gets you the right answer 100% of the time, but if you can't factor, if you forgot, let's say you're in the quiz and all of a sudden your brain just completely goes blank on how to factor anything, numerical chart still works, just not as accurate. You have to be a little more creative in what you get as an answer.
You still get more